Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. What if I told you that the largest structure in the universe is so massive that it defies everything we understand about scale? Imagine something so vast that it stretches across the cosmos, spanning over 1 billion light-years, an immense cosmic web that challenges the very fabric of space itself. This isn't just a new galaxy or a distant supercluster of galaxies. It's an object so colossal, it redefines the idea of what large really means in the universe. A structure so big, it might even make you question our place in the universe. Scientists have just uncovered the Hercules-Corona Borealis Great Wall, the largest known structure in the universe. This discovery, which was made over 10 billion light-years away from Earth, is so staggeringly enormous it could fit an entire galaxy cluster and still have room to spare. To give you some perspective, our own Milky Way galaxy is about 100,000 light-years across. This Great Wall, on the other hand, stretches an estimated 10 billion light-years in length. That's not just large, it's absolutely incomprehensible to our everyday understanding of distance and size. Imagine light traveling at the fastest speed known to humankind, 75,000 kilometers per second, yet it would take it over 10 billion years to travel across the span of this cosmic giant. How can something so large even exist? How could a structure this vast, this incomprehensible, remain hidden from scientists for so long? That's the key question this discovery raises. This cosmic wall isn't a solid structure as you might imagine, like a barrier in space. No, it's a colossal filament, a long thread-like structure formed from galaxies, gas, and dark matter, interconnected in a vast cosmic web. The Hercules-Corona Borealis Great Wall is not a single thing, but rather an enormous collection of galactic clusters, all bound together by the invisible force of gravity, spanning across an area that is truly difficult to imagine. But how did scientists find it? And how did something so enormous go undetected for so long? To answer that, we need to look at the technology and the methods used to uncover this monumental structure. It's all about the tools we have at our disposal. The discovery of the Hercules-Corona Borealis Great Wall wasn't just some happy accident. It was the result of years of work, advanced telescopes, and cutting-edge technology. Astronomers didn't stumble upon this massive structure by simply looking at the sky. They had to carefully map the universe, searching for the faintest signs of distant galaxies and cosmic phenomena that could indicate the presence of something this enormous. For years, we've used different telescopes and observational techniques to study the universe, but it wasn't until recent advancements in technology that we could look deeper into the cosmos and detect something as far away as the Hercules-Corona Borealis Great Wall. This isn't something we could have seen with the naked eye, or even with older telescopes. Instead, astronomers used a combination of cutting-edge radio telescopes, gravitational wave detectors, and deep space surveys to pinpoint the faint light from distant galaxies. This technology allowed them to map out the structure and recognize it as something far larger than anything we had ever discovered. But what makes this structure even more fascinating is its size. Imagine, this cosmic filament is so vast it makes other large cosmic objects seem small in comparison. For example, the Virgo supercluster, which includes our Milky Way galaxy, is often thought of as one of the largest known structures. It spans about 100 million light-years, but compared to the Hercules-Corona Borealis Great Wall, the Virgo supercluster looks like a mere speck on the cosmic canvas. This puts into perspective just how large this newfound structure really is. It's not just a cluster of galaxies, it's a sprawling network of galaxies and dark matter that is connected in a web-like fashion, spanning across vast regions of space. The discovery of the Hercules-Corona Borealis Great Wall challenges a lot of what we know about the universe. For centuries, scientists have tried to understand the large-scale structure of the universe. We've identified galaxy clusters, superclusters, and even voids, regions of space with very few galaxies. But this structure breaks the mold. It's a filament, a thread in the cosmic web that's far larger and more interconnected than we previously imagined, and it raises a question that's been at the core of cosmology for decades. How do such massive structures form? One of the most fascinating aspects of this discovery is how it challenges our understanding of the universe's formation. Theories of cosmic evolution suggest that the universe, in its early stages, was more homogeneous, with galaxies and matter evenly distributed throughout space. But over time, gravity began to pull matter together, forming galaxies, clusters, and eventually the large-scale structures we see today. The Hercules-Corona Borealis Great Wall is one of the largest remnants of this process, and it shows us just how the universe has evolved over billions of years. But if this structure is so massive, where does it fit into the grander scheme of the universe? Is it just the beginning of more discoveries like it? Are there other massive cosmic walls, filaments, or even structures larger than this one, hidden in the uncharted territories of the universe, waiting to be uncovered? The discovery of this Great Wall leads us to wonder what other cosmic giants are out there, just waiting for the right technology and human ingenuity to reveal them. This massive structure also prompts deeper questions about the nature of dark matter. Dark matter is the mysterious, invisible substance that makes up about 27% of the universe. We know it exists because of its gravitational effects on galaxies and other cosmic objects, but we can't see it directly. The Hercules-Corona Borealis Great Wall is thought to contain a large amount of dark matter. This invisible material that plays a crucial role in the formation of galaxies and large-scale structures. Understanding how dark matter contributes to the formation of such a massive structure could unlock even more of the universe's secrets. Now let's take a moment to think about the philosophical implications of this discovery. The scale of the Hercules-Corona Borealis Great Wall is beyond our comprehension. It's so vast that it makes you feel small, tiny even, when you think about the sheer scale of it all. But in that smallness, there's something awe-inspiring. It reminds us that we are part of something so much larger than ourselves, something that stretches across unimaginable distances, and that, despite our smallness, we have the ability to understand and explore it. Every discovery, no matter how small, brings us closer to understanding the vast, unfathomable universe we live in. And with each discovery, we begin to see the bigger picture, one that's made up of massive structures, invisible forces, and cosmic webs that stretch across the entire universe. The Hercules-Corona Borealis Great Wall is just one piece of the puzzle, but it's an important one, and it reminds us that there's always more out there to discover. So what do you think? Is this the largest structure we'll ever find, or could there be even more monumental discoveries hidden in the far reaches of space? Stay tuned as we dive deeper into the science behind this discovery, exploring what it means for our understanding of the universe and our place within it. Now that we've uncovered the awe-inspiring size of the Hercules-Corona Borealis Great Wall, it's time to dive deeper into what it actually is, how it was formed, and what it tells us about the universe's fundamental structure. We've seen the numbers, the mind-blowing distances, and the immense scale of this cosmic titan. But what does it really mean to have discovered something this colossal? And how does a structure like this come into existence? To understand that, we must explore the very building blocks of the universe itself. At its core, the Hercules-Corona Borealis Great Wall is a massive cosmic filament, a thread-like structure made up of galaxies, gas, and dark matter. These filaments are part of a vast network that forms the cosmic web, the large-scale structure of the universe. The cosmic web is not just a scientific metaphor. It's the actual arrangement of matter in the universe, a network of interconnected structures formed by gravity. Galaxies, galaxy clusters, and superclusters are all connected by vast, invisible threads of dark matter. Think of it like a giant spider's web stretching across the cosmos, with galaxies at the intersections held together by the gravitational pull of dark matter. To fully appreciate the magnitude of the Hercules-Corona Borealis Great Wall, we need to understand how filaments like this one fit into the grand structure of the universe. Over the course of billions of years, the universe has evolved from a nearly homogeneous state, where matter was more or less evenly spread throughout the cosmos, into the web of galaxies and clusters we observe today. This process is called cosmic evolution, and it's driven by gravity, dark matter, and the expansion of space itself. After the Big Bang, the universe was a hot, dense soup of particles. As the universe expanded, matter began to cool and condense. Gravity played a central role in pulling matter together, forming clumps that would eventually become galaxies. But the universe wasn't just expanding outward, it was also developing. Its structure. Over billions of years, the matter that was pulled together by gravity started to form into clusters of galaxies, and these clusters began to form larger structures like superclusters and filaments. The Hercules-Corona Borealis Great Wall is a prime example of one of these filaments. But unlike typical galaxy clusters, which are more compact and spherical, filaments are long, thin strands that stretch across vast distances. They connect multiple galaxy clusters and superclusters, forming the edges of massive voids in the universe, huge empty spaces that are devoid of galaxies. These filaments are the scaffolding of the universe, holding everything together. They're where the majority of the universe's visible mass, in the form of galaxies, resides. But it's not just the galaxies that make the Hercules-Corona Borealis Great Wall so fascinating. It's also the dark matter. Dark matter is the invisible substance that makes up about 27% of the universe's mass. It doesn't emit, absorb, or reflect light, so we can't see it directly, but we know it exists because of its gravitational effects on galaxies and other visible matter. Dark matter acts like an invisible glue, holding galaxies and galaxy clusters together. Without dark matter, the Hercules-Corona Borealis Great Wall wouldn't be able to exist. It's the dark matter that gives the wall its structural integrity and allows it to stretch across such vast distances. The discovery of this structure is a breakthrough in understanding how dark matter shapes the universe. For years, scientists have theorized about the role of dark matter in the formation of large-scale structures, but until now, we didn't have direct evidence of how it could be organized on such an enormous scale. The Hercules-Corona Borealis Great Wall is one of the largest known concentrations of dark matter in the universe, and studying it could provide valuable insights into the nature of this mysterious substance. So how did astronomers even spot this giant structure, hidden billions of light years away? It all comes down to modern observational technology. The key to finding the Hercules-Corona Borealis Great Wall lies in the detection of faint signals from distant galaxies. But here's the catch. These signals are not just any light. The CY. Galaxies that make up this structure are incredibly far away, and their light has taken billions of years to reach us. In fact, the light from these galaxies left them before we even had the technology to detect them. What we see today is a snapshot of the past, a glimpse of the universe as it was billions of years ago. To catch these far-off signals, astronomers use advanced telescopes like the Sloan Digital Sky Survey, SDSS, which maps the sky in great detail and collects data on millions of galaxies. These surveys allow scientists to create 3D maps of the universe and spot the faintest traces of distant galaxies. By analyzing the light from these galaxies, astronomers can infer their positions, velocities, and whether they're part of a larger structure, like the Hercules-Corona Borealis Great Wall. But the challenge doesn't end there. To detect a structure, this vast astronomers must sift through mountains of data. The Hercules-Corona Borealis Great Wall was discovered using a technique called redshift, which measures how the light from distant galaxies shifts toward the red end of the spectrum as they move away from us. By measuring redshift, astronomers can determine the distance to a galaxy and map out the large-scale structure of the universe. The Great Wall was identified as an enormous concentration of galaxies and dark matter stretching across billions of light years, standing out as one of the most massive and cohesive structures ever observed. So, what does the Hercules-Corona Borealis Great Wall tell us about the universe's evolution? First and foremost, it suggests that the universe's large-scale structure is much more interconnected than we ever imagined. Filaments like this one aren't just random arrangements of galaxies. They're the result of billions of years of cosmic evolution, shaped by the invisible hand of gravity and dark matter. This discovery underscores the importance of dark matter in the formation of large-scale structures and provides a clearer picture of how galaxies and galaxy clusters are connected in the cosmic web. But even more intriguing is what this structure could reveal about the future of the universe. The Hercules-Corona Borealis Great Wall is still evolving, just like the rest of the universe. As gravity continues to pull galaxies together, filaments like this one could continue to grow, merging with other cosmic structures to form even larger walls and superclusters. The future of the universe, it seems, is written in these vast interconnected filaments. As we stand on the edge of this discovery, we can't help but wonder what other monumental structures lie hidden in the far reaches of space, waiting for our technology and our curiosity to uncover them. The Hercules-Corona Borealis Great Wall is just one chapter in a story that's still being written, and who knows what secrets the universe holds yet to be discovered. This discovery challenges our understanding of the universe, showing us that the cosmos is not just a vast, empty expanse, but a place of intricate connections where matter, energy, and dark forces intertwine to create structures of unimaginable scale. And as we continue to explore and study these cosmic giants, we're bound to uncover more about the nature of reality itself. So what's next? Are we just scratching the surface of something much bigger? Could there be other, even larger cosmic structures lying just beyond the reach of our telescopes? The journey to understand the universe has only just begun, and every new discovery, like the Hercules-Corona Borealis Great Wall, brings us one step closer to unraveling the mysteries of the cosmos. Now that we've delved into the vastness of the Hercules-Corona Borealis Great Wall and explored its fundamental structure, it's time to zoom out and reflect on what this discovery truly means on a grand scale. As incredible as this structure is, it raises profound questions about the nature of the universe itself, questions that challenge the very way we think about space, time, and the future of our cosmos. To begin, let's think about the implications for our place in the universe. The discovery of the Hercules-Corona Borealis Great Wall isn't just a mind-bending fact about some far-off corner of the cosmos. It's a reminder of how small we are in comparison. Sure, we all know the universe is big, but when you consider that this Great Wall stretches across 10 billion light-years, it forces you to confront just how tiny Earth is in the grand scheme of things. Imagine standing in a vast ocean, and you see a massive, seemingly infinite wall stretching across the horizon. It's overwhelming, isn't it? And yet, despite its incredible size, this structure is just one of many. Our universe is a patchwork of these colossal filaments, each one a colossal network of galaxies, dark matter, and gas, interwoven into the cosmic web. The Hercules-Corona Borealis Great Wall may be the largest structure we've discovered, but we're only beginning to scratch the surface of what's out there. Every new discovery seems to raise more questions than answers. How many more walls like this exist, hidden far beyond the edge of our observational reach? How many more mind-boggling structures are waiting for us to find them? And what will they teach us about the very fabric of the universe? In the world of cosmology, one question stands out above all others. What is the ultimate fate of the universe? For centuries, scientists have proposed various theories about how the universe might end. Some envision the Big Freeze, where galaxies drift farther and farther apart, the stars burn out, and the universe becomes a cold, dark void. Others predict a Big Crunch, where gravity causes everything to collapse back into a singularity, a point of infinite density. And there's the Big Rip theory, where the accelerated expansion of the universe tears everything apart, from galaxies down to atoms. But what if the discovery of massive structures like the Hercules-Corona Borealis Great Wall offers a clue to the universe's ultimate fate? In a way, these filaments of galaxies are like the skeleton of the cosmos, the bones that hold everything together. If the universe continues expanding, will the filaments stretch so far apart that they break down, leaving behind a scattered, isolated cosmos? Or will the gravitational pull of these colossal structures eventually cause them to collapse inward, perhaps leading to a new chapter in the universe's life cycle? It's a fascinating thought, and as we learn more about how these filaments behave, we gain valuable insights into the cosmic forces that govern the universe. The Hercules-Corona Borealis Great Wall isn't just a static object in space. It's a dynamic living part of a constantly evolving cosmic dance. And the more we study it, the more we understand about the interconnectedness of galaxies, dark matter, and gravity. But let's take a step back and consider something even more fundamental. How did this structure come to be? We know the basic mechanics. Galaxies formed, clusters merged, and gravity and dark matter shaped everything into the cosmic web we see today. But the really intriguing question is, why is the universe arranged this way? Why are galaxies not scattered randomly across space, but rather grouped into these massive filaments and clusters? The answer may lie in the very nature of space-time itself. In Einstein's theory of general relativity, space and time are not separate entities, but are part of a unified fabric known as space-time. Massive objects like galaxies warp this fabric, creating what we perceive as gravity. This warping doesn't just happen at the level of individual objects like stars or planets. It happens on the largest scales, influencing the distribution of galaxies across the universe. In a sense, the Hercules-Corona Borealis Great Wall and other cosmic structures are the result of a deep, fundamental property of space-time. The massive gravitational influence of dark matter and galaxies has shaped the very way space itself is structured. But even more mind-blowing is the possibility that these filaments, like the Hercules-Corona Borealis Great Wall, could be the result of an even more mysterious force: dark energy. Dark energy is the name given to the force that's accelerating the expansion of the universe, pushing galaxies apart at ever-increasing speeds. While dark energy is still a huge mystery, it could be playing a key role in the formation and evolution of large-scale cosmic structures. In fact, some scientists speculate that dark energy may be responsible for the way cosmic filaments are arranged. Could the expansion of the universe itself be responsible for pushing galaxies into these vast threads, stretching them out into filaments as the universe continues to expand? At this point, the story becomes even more mind-bending. Imagine this: cosmic web stretching across billions of light-years, each filament not just holding galaxies together, but possibly influencing the very way time and space behave. These structures could be the key to unlocking the mysteries of dark matter, dark energy, and the very nature of the universe itself. By studying them, we might discover something that changes our understanding of reality in profound ways. And here's where things get really interesting. The discovery of such structures doesn't just help us understand the past, it also informs the future. As we continue to refine our telescopes and expand our observational capabilities, we might begin to uncover even larger structures, perhaps even structures that are older than the Hercules-Corona Borealis Great Wall itself. If we could observe the earlier stages of these filaments, could we gain insights into the conditions that existed just after the Big Bang? Could we witness the birth of the cosmic web as it began to form billions of years ago? It's a tantalizing thought, one that stretches the limits of our imagination. And it's not just about the past. The study of these massive structures could also provide us with a glimpse into the future of the universe. How will these filaments evolve as the universe continues to expand? Will they grow even more complex, or will they eventually break apart as dark energy accelerates the expansion? These are questions we can't yet answer, but each new discovery, like the Hercules-Corona Borealis Great Wall, brings us one step closer to understanding the ultimate fate of the universe. As we look to the stars and contemplate the future of the cosmos, we can't help but wonder, if we can unravel the mysteries of structures like the Hercules-Corona Borealis Great Wall, what other hidden wonders of the universe are out there, waiting for us to uncover them? What secrets does the cosmos still hold, just beyond the edge of our reach? It's a journey that will take us deep into the heart of the universe, into realms we can barely comprehend. But as we continue to explore, we come ever closer to unlocking the answers that have eluded humanity for centuries. Now, as we reach the final leg of this incredible journey, we're faced with a question that brings us full circle. What does the discovery of the Hercules-Corona Borealis Great Wall mean for humanity's future in space exploration? It's easy to look at these vast cosmic structures and feel small, insignificant even, as though we're mere specks in an endless universe. But that very realization, our smallness in the grand scheme of things, could be the spark that propels us forward into the next era of exploration. It's one thing to study space from a distance, through telescopes and theories. It's another to venture into it, to send humans to other worlds, to explore the boundaries of the cosmos and unravel its deepest secrets. The discovery of structures like the Hercules-Corona Borealis Great Wall offers us a glimpse into the grand architecture of the universe. And for the first time in human history, we can begin to comprehend the scale of what's out there. Imagine, just for a moment, a future where we've broken free of Earth's gravity and set foot on distant planets, exploring the very structures we once thought were too far out of reach. The possibility of interstellar travel, of humanity becoming an intergalactic species, has gone from science fiction to an achievable dream. It's no longer just about getting to Mars or building permanent bases on the Moon. We're looking at the potential to explore other star systems, to send probes into the deep expanse of the Milky Way, and perhaps one day to reach beyond our galaxy itself. The discoveries we make in the next few decades, perhaps even centuries, could pave the way for us to interact with these enormous structures we now see from afar. Consider the technological leap that has already taken place. In just the last century, we've gone from launching crude rockets into the sky to sending spacecraft like the JWST to the farthest reaches of our universe. The fact that we can now observe galaxies billions of light years away is mind-boggling. And as our technology advances, so too will our ability to study these galactic webs in even greater detail. The next generation of space telescopes will give us even sharper views of these structures, revealing the hidden forces and intricacies of the cosmic web. Could we one day see the birth of new walls, filaments, and clusters forming? The possibilities are endless, but even as we contemplate the future of space exploration, we must remember that these discoveries are not just about the future, they're also about the present. The study of the Hercules-Corona Borealis Great Wall and similar structures opens the door to a deeper understanding of some of the most profound mysteries of the universe: dark matter, dark energy, and the very nature of gravity itself. These cosmic filaments are not just distant phenomena, they're key to understanding how our universe behaves. By studying their formation and evolution, we can learn more about the fundamental forces that shape the cosmos, offering insights that could drive technological innovations here on Earth. After all, many of the greatest breakthroughs in science have come from trying to understand the cosmos. The study of space has already led to advancements in computing, materials science, and telecommunications. Imagine the possibilities if we can unlock even more of the universe's secrets. Now think about the implications this discovery has on the search for extraterrestrial life. As we explore the vast filaments and walls of the universe, we're not just looking for new stars and galaxies, we're looking for signs of life. The Hercules-Corona Borealis Great Wall may be a staggering object of interest, but it's also a key to understanding where life might thrive. Scientists believe that the best places to search for alien civilizations could be in the dense regions of cosmic filaments, where galaxies cluster together. These areas are rich in matter and energy, key ingredients for life to evolve. Could we be on the brink of finding a distant civilization within these vast structures? The discovery of this Great Wall pushes the boundaries of where we think life might exist, helping us narrow our search and open our eyes to new possibilities. At the same time, this discovery reminds us of how much more there is to learn about the fundamental laws of the universe. The Hercules-Corona Borealis Great Wall is not just the largest known structure in the universe. It's a cosmic puzzle that challenges our understanding of physics. If such a massive structure can exist, stretching across 10 billion light-years, how does that influence our theories of gravity, space-time, and the forces that govern the universe? In the years to come, as we continue to refine our models and tools, we may need to rethink everything we thought we knew about the cosmos, and that in itself is both humbling and exciting. So where does all this leave us? The discovery of the Hercules-Corona Borealis Great Wall is more than just a breakthrough in space science. It's a call to action for the next generation of scientists, engineers, and explorers. It's a reminder that we are still at the dawn of understanding the universe, and while we may never fully comprehend the vastness of it all, our curiosity and our desire to explore will always push us forward. As we continue to look deeper into the cosmos, we're bound to make even more astonishing discoveries, each one building on the last, expanding our knowledge of the universe and our place within it. And as we stand on the edge of the unknown, one question lingers in the back of our minds: what will we find next? If you've enjoyed this journey through the cosmic wonders of the universe, make sure to give this video a thumbs up and share it with fellow space enthusiasts. We'd love to hear your thoughts and questions. What do you think about the Hercules-Corona Borealis Great Wall, and what mysteries of the universe do you hope we'll uncover next? Leave a comment below and join the conversation.